A 5-kilogram cart moving at 5 meters per second has an inelastic collision with a 10-kilogram cart moving at 2 meters per second. What is the velocity of the two carts after the collision? So one of the key words here is inelastic collision. Remember, an inelastic collision is a collision where the two objects stick together. So they're going to be moving separately, they're going to crash into each other, and then they're going to move together after the collision. So another thing to remember is the law of conservation of momentum says that the momentum before the collision is going to be the same after the collision. So first we have to figure out the momentum before the collision. So we have a cart number 1 and a cart number 2. Okay? What is the momentum of cart number 1? Well, we know that momentum is mass times velocity, so we're going to do 5 kilograms times 5 meters per second to give me 25 kilogram meters per second. Okay? And then cart number 2 we said was 10 kilograms moving at 2 meters per second. 10 times 2 is 20 kilogram meters per second. So what's the total momentum before the collision? 25 plus 20 is 45 kilogram meters per second. Okay? So then they crash into each other. What has to be the momentum after? Has to be 45 kilogram meters per second, correct? So when it's an inelastic collision, they stick together. So what's their total mass going to be? So it was 5 kilograms, and then it crashed into a 10 kilogram cart. They stuck together. Their total mass is 15 kilograms. So now all we have to do is work backwards. Momentum equals mass times velocity. We said our momentum was 45 kilogram meters per second because that's what it was before and that's what it has to be afterwards. We said our mass was 15 kilograms because that's what the two carts added together are because they stuck together, times velocity. Now remember, okay, we're working backwards. We have to divide. Okay, so what is 45 divided by 15? 3.